the information that we needed to collect was the initial conditions. The initial pressure was 2000, the initial temperature was 75.2, the component was CO2, and the volume was 10 cc's of liquid. And then we generated a table which we collected the pressures, the volume of gas, volume of the liquid, volume of the mercury injected or removed, and the total volume. So we started with the pressure, 2000 psi, when we had 0 gas and 10 cc's liquid. So the total volume was the 0 plus 10, which is 10. And then we removed mercury, and then we start dropping the pressure by expanding the liquid. So the liquid expanded to 11 cc's. The total volume was 11, and then we continued till we get to this point. So at this point, the volume of the gas becomes 0.002. If you remember, we said if the volume of the gas becomes 0.001 or 0.002, that can be considered as the first gas bubble. So this is our bubble point pressure. Okay. So we got our bubble point pressure. And if you see, we didn't collect any point that we passed the bubble point. We just collect the points where we are all in the liquid phase till we hit the bubble point. When we hit the bubble point, if you pay attention, by removing more mercury and converting the liquid to the gas, the pressure stayed constant. So the pressure stayed constant while I'm converting the liquid to the gas. So here I had 13 cc's of liquid, then I dropped to 7, then 1, and I continued this till I have only 0.001 cc of liquid. And that's basically considered the smallest amount of liquid we can collect. So that's my dew point pressure. Okay, so I got my dew point pressure. So I got my bubble point pressure and I got my dew point pressure. And as you can see, the bubble point pressure stays equal to the dew point pressure and it stays constant equal to 914. This was one of the major properties of the single component. Okay, so for all the pure components or single components, as we discussed in the class, the bubble point pressure will be equal to the dew point pressure will be equal to the vapor pressure. Okay, but after that, when we go to the gas phase, we have the pressure will drop. So this is the data that we collected and you need to report. And for plotting, we said we are going to plot the pressure versus the total volume. And remember, this is the total volume is simply the gas volume plus the liquid volume. We don't care about the mercury. This is the volume of the liquid. And then I'm going to plot. Okay. So here what I have is we have the total volume in cc okay, and the x-axis what I have is, in the y-axis what I have is the pressure in psia. And this graph is pressure versus volume graph. Okay, so I just need to make this a little bit nicer. So increase the font such that one can read. So I'm going to change the axis. I'm going to change this from, let's say, 500 to 2000. Okay. So sometimes it's a good idea to plot pressure versus normalized volume. That basically makes your graph look nicer. Okay. So this is our graph. Okay, and as you can see, there. Oh, this is the other way around. Okay, so let me change the scale. So my x-axis, I want it to be the total volume. And my y-axis, I would like to be the pressure. Okay. And I'm going to just do some cosmetics to make sure that this reads well. Okay, so this is our graph. As we said, we can draw the best straight line going through the data points. So this is my best straight line going to the data points. So this is my liquid phase, and then I'm going to have my best straight line all the way to here. This is where I have my two phase, and then at the end I have my third slope. And that's my gas phase. So I can also show points. So this is where I have my PB bubble point. Here where I have my PD, dew point pressure. And here is my two-phase region. So here I have my two-phase. Here I have my liquid. My liquid and my gas. And this is a pressure versus volume diagram of CO2. Okay, and this basically becomes my graph. So if I compare this with the theory, it says by a small change in the volume, the pressure drops significantly till I hit the bubble point. The bubble point stays constant all the way till dew point, and after that I have the gas phase. So basically what I could do, I could recover what the theory says about the single phase behavior pressure volume So in your lab report, you need to have this data as your results and the graph, and then you need to discuss the graph, describe every part of this, and then compare this with the theory which is presented in the book and make some conclusions. So basically the conclusion is the bubble point is equal to dew point equal to vapor pressure. So through the two phase for the single component, the pressure will not change. Okay. And as I said, you need to go over the lab manual posted and the guidelines for the lab report. And the deadline for this lab report is next week on Wednesday. So you need to complete the lab report and submit it through the in-campus by next week, Wednesday. Okay. And send me an email if you have any question regarding this lab, and if you need more clarification, then I can come back to you. Okay. So that's it for today, and I'll see you guys next session.